Well, as Geoff said, IGN is a French national mapping authority in charge of describing the territories for over than 300 years. And of course, this description is made for multi-usage, for example, transportation, city planning, leisure. To be honest, in the 17th century, it was essentially for military reasons, of course. But in fact, now, land description is made for lots of other use. First of all, we can set a little the context for the question of infrastructure. Of course, we saw that with the previous speaker. We can say that developing smart infrastructures mean taking their efficiency, their sustainability, their resiliency, and their consumption of energy, and to take all together in account. This implies to deal with a great variety of information because the amount of data that is exchanged about infrastructures is larger and larger, and because those data deals with a range of issues that is wider and wider. Moreover, the sources of the data are more and more decentralized. Georeferencing is also an important characteristic of those data because it helps crossing different data sets, which creates further intelligence and added value. Then this leads to questioning about how geospatial information is essential to respond to the key challenge of infrastructure development, and further on how to improve the response to these challenges. I'm going to address this issue through several examples. Optimization of mobility and transport, three-dimensional city design, and infrastructure optimal planning. First of all, the question of transportation. Of course, one of the oldest infrastructure transport networks are still fundamental for the development of any community. The management of road congestion, for example, is a major challenge. It requires a fine-tuning of road networks, such as safe traffic lights, smart opening of relief roads, or smart message to drivers. It may save billions of hours per day, as well as millions of tons of greenhouse gases. Such fine-tuning requires quality basic geospatial data that is highly accurate description of the road network, which can be enriched by road operators with data describing the infrastructures. For example, data about asphalt quality, data about traffic flow, real-time information such as floating car data, and so on. The development of transport intermodality, which is now a great challenge for the next year, is also a key target. High-quality intermodal transport systems have to be available for citizens in both urban and rural areas. As example, public transport timetables should be coherent, car parks should be developed close to the railway station, intermodal itinerary calculation systems should be set up, and of course the information should be delivered to the citizen on time, and this is not the simplest challenge. Designing such smart intermodal system requires sophisticated spatial analysis. Mobility requirements have also to be reduced, for example, by moving people residences and office closer. This setup of corporate mobility plans precisely aims at responding to this issue. Spatial studies enable either to optimize the localization of FSCs or to define strategies such as financial intensive to incite employees to use public transport. And we work a lot on this topic at this time. Referencing road referencing road reference points upon a topographical database enables to merge two reference systems that are used in the transport community. This allows data interoperability and supplies a reference frame as required by intelligent transport system. Besides, some research and development projects that are going on aim at detecting the road components automatically by image processing. Detected components are especially road and street sections, sidewalks, zebra crossings, obstacles within roads and streets. Some other research and development projects are also developing mobility simulation systems on such data. Such systems depend, of course, on the nature of the considered mobility. For example, for firemen trucks, ladder and obstacles, for handicapped persons, steps and curbs are obstacles. The maintenance, of course, on transport infrastructure is a key aspect, and Chris Gibson took us about that. Metrology has to be used to monitor major transport infrastructures, such as bridges and tunnels. For example, dilatation effects due to heat can move bridges and up to 30 centimeters. Digging subway routes also have an impact on the ground and on the stability of buildings. A steady and accurate monitoring is therefore very important to preserve its integrity and user safety. Such monitoring requires accurate geospatial geodetic frames. Let's go now to the second issue I will to address to you. This is a three-dimensional city design. Of course, in urban areas, infrastructure development is a matter for a larger scope of city design. An important issue of this is to embody and communicate the three-dimensional vision of urban planners and architects. So far, town planning schemes have only been represented in 2 dimensions. Moreover, 2 schemes have failed in representing the dynamics of city phenomena. The rise of three-dimensional is unlocking this difficulty. Three-dimensional models provide a better vision of the city and enable innovative GIS analysis capacities to deal with these new issues. For example, heat island phenomena can be anticipated by assessing sunlight and shade. Modeling prevailing winds facilitates pollution evacuation. Compliance with urban planning regulations can be modeled and computed. The dynamic of place will also be modeled thanks to the integration of time in geographic information system. This will enable to assess both short-term dynamic, such as crowd management for a given event, or long-term evolution. Digitizing and integrating town planning schemes into national spatial data infrastructure, in conformance, of course, in Europe with the INSPIRE directive, enables to better understand and better comply with the obligations of urban planning regulations. This leads to new e-government service, saving users' time and increasing administration efficacy. So far, town planning schemes have only been designed in 2 dimensions. However, town planning schemes now contain regulations dealing with a 3rd dimension, for instance, buildings 8. And this is why, of course, an actual project is to fully integrate the 3 dimension in urban planning. In this example, 3-dimension LOD 2 model overlaying the cadastre and the topographical database enables to integrate the land use constraints such as maximal number of floors, minimal distance between the walls and the parcel edges, maximal height, adjacency with the road of given width. This allows to determine the maximum constructible volume. Again, going further in that direction will require innovative GIS capacities. For the city design, we can compare urban areas over history, and it enables to assess the development of a city and to detect the relative importance of the different topographic features in the development of each place of the city. Impacting features are mainly infrastructure facilities, settlements, and natural features such as the relief. Such comparison may also enable to forecast the patterns of the city in the long term by detecting generic evolution patterns and classifying each place into one of these patterns. This requires, of course, scanning and georeferencing the maps available over time and digitalizing urban extensions. Lots of work is done now on this topic, and we are now able to preview what will happen. Well, geospatial information is also essential to address infrastructure optimal planning at the territory scale. Shaping a territory evolution means thinking on a long-term basis and from various perspectives. A social perspective, who are the people living in the territory, how to enhance social diversity. An economic perspective, what are the current businesses of the territory? What are the opportunities? What should be done in order to raise them? And of course, an environmental perspective, how should the surroundings structured? What should be done to integrate human activity smartly? What are the places and biodiversity corridors to maintain? In order to cope with those issues, the interrelations of the different networks that make up the territory must be apprehended in order to raise its coherence as well as its resilience after a major event. Such as transversal approach breaks the former purely function-driven and silo approach in order to analyze the interactions. For example, in case of a major event, a power record will generate a mobile phone disruption. Other means of communication will therefore be necessary to coordinate the rescue. Naturally, such approach requires also accurate and up-to-date geospatial descriptions of those networks. In addition to networks, blocks are appropriated level to analyze the territory. For example, urban infrastructure impacts social life. It is therefore important to take into account the social experience over time and the spatial behavior of inhabitants around existing infrastructures in order to avoid the creation of new urban enclaves. This requires using GIS functionalities to create smarter spatial indicators. Well, in this free example, I think we showed that our geospatial information is essential to respond to the key challenges of infrastructure development. They also what kind of effort have to be made in order to improve the response of geospatial information to those challenges. First, we have to make efforts to improve the geospatial information which is available. Indeed, geospatial data should fulfill precise requirements so that thematic and application data related to infrastructure can rely on them. The first requirement deals with quality. Infrastructure development requires geospatial data with high accuracy and high freshness. Its quality should be assured, which means that the sources and the production processes of this data should be transparently documented. A second challenge is that infrastructure development requires reference geospatial data. Reference data means that those data are recognized by all public and private players as a common base to work together. Such common base enables interoperability, which is to say combining and crossing many kinds of data. Infrastructure development requires also authoritative geospatial data. Many regulations can be georeferenced. If they are actually georeferenced, they will be more smartly applied. Hence, the possibility for regulations to rely on geospatial data is a big stake. This is why there is a requirement for authoritative geospatial data, which means data enabling regulations to be georeferenced. And at last, infrastructure development requires neutral geospatial data. It means data which is produced and maintained by a public authority that is not a stakeholder or an infrastructure development. It also means that the public authority maintains this data on the whole territory with equity and on quality requirements. It means either that using those data, you can be sure that your personal data won't be used while using those data. Well, Geosmart infrastructure also requires improving and reshaping the organization of the producing and the managing of those infrastructure. First of all, the consistency of reference data at a regional as well as global scale should be ensured. In a more and more integrated society, physical infrastructure are developed at cross-border scale. To be useful, geospatial infrastructure should follow this trend. Secondly, the cooperation between national mapping and cadastral agencies should be improved. We should provide better reference data specifications according to the user needs, and we should provide thematic services to users to use those data. And last but not the least, information and communication technologies may bring new value chains and therefore new economical models for both physical infrastructure and geospatial infrastructure. Such new models will certainly involve the private sector, the public sector, and the citizen. Well, I hope that with this example, I have convinced you that we have a great future for geospatial data and for the use of those data in the infrastructure development. Thank you.